An exercise machine is designed to be lightweight cart on an inclined ramp on which a lady may lie and hold herself with the two parallel strings. First of all, there are many hidden layers in this particular question. Okay, so we need to understand each and everything properly. The first idea, the first key point in this question is lightweight, which means the cart, whichever, see here you could see there was a ramp, right? So this entire layer, just first of all highlighted. This is the ramp. Okay, something like you can consider that some kind of a table setup arrangement or something like that. In that ramp, there is a cart. Okay, the small cart. Here it is. This is the cart. Okay, in the ramp, there is a cart. And they clearly mention that the cart is lightweight, which means weight of that particular cart can be approximately assumed to be 0. You can neglect neglect the weight of the cart. Okay, right. And the inclined ramp's angle is given 15 degree. Okay, 15 degrees the angle at which the ramp is inclined, that is given. And you could clearly see the next keyword, two parallel strings. Okay, this is obvious. This particular woman is going to have two hands. So in one hand, he is going to hold one string, and in the other hand, he will be having other string. So there are two strings with the two hands. She is holding both the strings. Okay, so here there will be two strings. If suppose I take the tension in one string is T, okay, because it is a two-dimensional figure, we won't able to see two strings here. But you could understand that, I believe, because there will be one more string if you see the three-dimensional one. That is, if you see the perpendicular to the paper, that is perpendicular to the screen, there will be two strings, right? So one string will be there with one hand, another string will be there in the other hand. So total tension is going to be 2T, where T is nothing but tension in one string. And you could clearly see the string is moving, and it is passing through frictionless pulley. That is the third key point. I will highlight all the key points. First one, it is lightweight. Cart is lightweight. Cart is lightweight. Second one, there are two parallel strings. Okay. See, with the first key point, I was able to understand that the weight of the cart can be approximately made as 0. And with two parallel string, I can understand total string or total tension in the strings will be 2T, okay, where T is nothing but tension in one string, okay. And the third key point is frictionless pulley. Okay, the pulley is frictionless. So whatever the tension this string is carrying, the same tension only this string will also carry. So this string, that is the top string, the two strings which is present in top. Okay, similarly, the two strings which is present in bottom, that will also have same. I'm sorry, I'll just erase this. That will also have same tension. Okay, that will also have same tension 2T. And let us continue. And you could see that that strings was attached to the cart. Okay, it is attached to the cart on which the woman is lying. Okay. Now, if the lady weighing, so weight of the lady is given, okay, which is 700 Newton, is able to pull and keep the strings horizontal. So she is pulling it, okay, she is pulling it and maintaining the string to be horizontal, while the ramp is inclined at 15 degree, which is already there, which is clearly there in the, what is that? Clearly there in the diagram itself. Determine the force she is exerting by each hand. This is nothing but T. Okay, they are not asking 2T. Totally, he is exerting 2T amount of force. Okay, totally the tension will be 2T. So obviously she is exerting 2T amount of force, but they are not asking 2T. They are asking only T. Okay, right. Now find also the reaction of the ramp on the cart, and also they are asking us to find out reaction. Okay, see, first of all, I will try to draw the free body diagram for the cart and that woman combinedly. Okay, because cart is weightless. Okay, and I will take that woman also. So combinedly, okay, this is the woman and this is the cart. Okay, and if I draw the free body diagram for this, then one more question I have. Do I need to treat this cart and ramp, that is cart and the woman, to be a particle, or does it need to be a rigid body? Cart and woman combinedly.
Particle, sir.
And it is a particle because there is no dimension. So it is simply a particle. So I'm not going to treat, I will just take it as a point. Okay, simply a point. And this point represents cart plus woman. Okay, right? Right? Tension 25. Wrong. No, wrong. Hari, just listen. This is a very good question. I was explaining you unnecessarily. You are wasting your time and solving it. Okay, listen. So there will be a reaction here, right? There will be a reaction here. So that I will consider it like this: a reaction, and a tension 2T, which is acting on cart. Okay, tension 2T, which is acting on cart, and we already know that tension will be always. Suppose if I cut it, okay, if I cut it, tension will always act outward. So there is going to be tension 2T. 1 second, I will do one thing. I will just extend this. Okay. Yeah, this angle is 15 degree. Okay. Right. So the tension is 2T, which will be always acting outwards. So tension will be always acting outwards, 2T. And this 2T is on the cart. Don't forget, this 2T is on the cart. But I'm considering both this cart and the woman to be my system, and that is completely a particle. Okay, that is completely a particle. Okay, right now, see this 2T, whatever I have taken, that 2T is this tension which is acting on cart. I need to consider this 2T also, because I'm treating both cart and woman to be the particle, right? So that 2T should also be considered. See, this diagram might confuse you, but we have taken this entire thing, okay, this entire thing to be a particle, okay, this entire thing to be a single particle. That is the woman and the cart completely to be a single particle. That is why I'm just taking it to be a single particle like this. So here, we'll use different color for this 2T, okay? Right. So this 2T will also be acting outwards, and it is horizontal, right? That is the fourth keyword I forgot to mention. It is horizontal. And also the fifth one, it's a particle, okay? Because dimensions are not mentioned. So it is a particle. So here it is 2T, okay? So this 2T is the tension on the cart. This 2T is the tension on the woman, okay? Right. Now, what are the other, any other? We have weight of the woman. Okay, weight of the woman is not considered. We should not consider weight of the cart because it is negligible, but weight of the woman should be considered, which will act downwards, which is W, which is 700 Newton. Okay. So overall, these are all the forces. Okay. Right. Any doubts here? It is not yet solved, but I'm just asking you until now. Was there any doubt?
Sir, அந்த ரியாக்ஷன் மென்ஷன் பண்ணிருக்கீங்களா சார்? ஆர் அங்க கான்டாக்ட் சர்ஃபேஸே இல்ல சார். நம்ம உமனையும்
rampல தான காட்ட வச்சிருக்கேன். I'm placing the
ஒரே சிஸ்டமா தான சார், பார்ட்டிகலா தான்.
Ramp is different, cart is different. Ramp is different, cart is completely different. That is why I highlighted that first. This is my ramp, this is my cart. I'm considering cart and the woman to be a single system. Ramp is separate. Okay, so this reaction is nothing but reaction offered by ramp on the cart.
Fine, sir. Fine.
Okay, this are okay, right. Okay, what about the angles? This is 15 degrees. I guess I can give the angle directly, right? This is 15. 1 second. I'll just modify the diagram in a little bit bigger way so that it will be easier. So this is 2T. And let me take, this is also 2T, okay? 2T and 2T. And this is my reaction R. And this is my weight W. Okay? See, this angle is 15 degree. This angle will also be 15 degree. Those are the basics which we already covered. So this will be 15 degree. Okay? And if this is 15 degree, I'll just extend it like this. Okay? If this is 15, then this will be 15. Okay, if that is 15, this will be 15. Yeah, with respect to the normal, right? This will be 15 degree. And what else? 1 second. This is horizontal. This line will be completely horizontal. Okay, this is 15 degree. Then this will be, what is that? 90 minus 15. So this will become 15 again. Okay, right? I hope there is no issues here regarding the angle. So what are all the angles I got? This angle is 15 degree. Oh, one second. Yeah, this angle is 15 degree and this angle is 15 degree. This is 2t, r and w, all those. Okay. And now I will find out summation of fx and summation of fy. Summation of fx equal to 0. I have 2t acting leftward. I will take leftward to be positive, so plus 2t. And this 2t, if I resolve it, I will be getting again 2t cos 15 degree. Okay. And then if I resolve this r, okay, if I resolve this r, horizontal direction, I will get minus r sine 15 degree, which is equal to 0. Okay. And another equation is summation of fy equal to 0. That will be, if I resolve this r again, I will be getting plus r cos 15. And w is acting downwards, so minus w. And 2t sine 15 is going to act upward. Okay, so plus 2t sine 15, which is equal to 0. I'm taking, in this case, I'm taking leftward to be positive. In this case, I'm taking upward to be positive. Okay, so find out the answer. That's it. So once if you drawn the free body diagram, then problem is 2 steps. Okay, so just you have to substitute all the data. You can find out the reactions. W is given. W is 700 Newton. W is 700 Newton. Okay, I will give you the answer. Okay, so tension is 46.5. That is correct. 46.5 Newton, and reaction will be 653 Newton. Okay, can solve and get the answer. I'm going to move to the next question.